నాకు షేర్ చేసింది. Okay, sorry for the interruption, you guys. Now we will discuss about the atomic structure and continuation of that fundamental particles topic. So discovery of electron we discussed. Electron discovered by J.J. Thomson in discharge tube experiment. Discharge tube means a glass long tube which is made by a glass and both ends connected with electrodes. One is cathode left side, anode right side. So at the cathode end we will connect high voltage battery around 10,000 volts. Okay, high voltage battery we will connect. Okay, so high voltage battery around 10,000 that will connect, and when you on that switch, what happens? And the particular cathode rays travels from cathode to anode. And one more important thing, in that particular cathode ray discharge tube, we only allow, actually, okay, we allow inert gases. Why inert gases? Why not normal gases? Few people ask me. Why inert gases? Inert gases are chemically stable. They cannot react. So if you are sending high voltage, normal molecules will break down. Certainly electron cannot eject easily. Okay, so that's why we have to take what? Inert gases. Got it, everyone? And one more important thing is cathode rays are traveling from cathode to anode and they are invisible. They are moving straightly. When they hit the fluorescent or phosphorescent screen, which is made up of zinc sulfide screen we use. Okay, so when you are using the zinc sulfide screen, what happens? Those cathode rays will hit the screen and they glow brightly. Correct? So that happens. Okay, and one more important thing is cathode rays are invisible and cathode ray will deflect in presence of external electric field and magnetic field, I said. Okay, hope you understood all those things. And cathode rays are independent on nature of gas, so electron will eject easily because electrons are around the nucleus, outside nucleus actually. Okay, electrons are revolving around the nucleus. Certainly whatever the gas, that's not a matter, electron will eject. We are sending high voltage. Got it, sir? So cathode rays are independent on nature of gas, and in presence of electric field, cathode rays are deflecting towards external anode. I told you like this. This is cathode ray path. We kept anode and cathode perpendicularly like this. So external anode we have. So those rays are just deflecting towards external anode. They are moving straightly. Understanding? So deflection happened due to some attractions. See, if this is my path, this is my starting point, and this is my ending point. Here I have ice cream, okay, which I like more. Certainly I will deflect towards ice cream. That's the attraction. Actually, this is my path, this is my ending place. Understanding why I'm saying like that? So here I have attractive thing, so definitely I will deflect. That deflection happened when external electric field, if you keep, then what happened? That electric field towards external anode, the cathode ray will deflect. I told you that. And towards magnetic field, if you keep a magnetic field, north pole and south pole, then what happened? Cathode ray will deflect towards north pole, I told you. So E/M ratio also I said. So next we have to discuss about discovery of discovery of proton. Discovery of what? Proton. How proton discovered? Proton discovered in just opposite way to cathode rays. So in a discharge tube only proton was discovered. So electron was discovered by J.J. Thomson. Proton was electron J.J. Thomson, and in a discharge tube experiment So discharge tube you have. Okay, here you have a discharge tube like this. Okay, so who discovered this? Means Goldstein. What, in what way? Just copied J.J. Thomson experiment. So what he said, cathode rays are traveling from cathode to anode. When you kept that particular high voltage battery at the cathode end, then Mr. Goldstein said, if you start sending that high voltage current from anode, then opposite to the cathode rays, some anode rays will travel from anode to cathode, he said. Means at that particular anode ray, they will move like this. So cathode rays are from cathode to anode like this. Correct answer. But now the rays are traveling in this manner. What is this? This is positive. Positive means anode or cathode? Anode. Okay. So this is what? This is a negative terminal. Negative terminal. Negative terminal is, sorry, negative terminal is cathode. This is what? Cathode. Okay. So what he said, opposite opposite to the path of cathode rays, anode rays are traveling. So anode rays are traveling from anode to cathode. This is the most important. These are also invisible. Means here you have a screen now. At the cathode terminal, you have screen here. So you are connecting with the high voltage battery. Same story. But now in this way. In this way you have. So here you have a high voltage battery. This is high voltage battery. Around how much I said? 10,000. Around 10,000 volts. So here you have high voltage battery. Okay. Okay. So what happened here? So this is the actually how proton discovered. How proton discovered? Proton discovered in a discharge tube, and the opposite to the path of cathode rays, anode rays also moving. Who observed? Goldstein observed. Okay, so those anode rays consist of some positive particles. Sir, how you are saying, sir? Those anode rays consist of positive particles, means they are moving from anode to cathode, means they are moving towards negative terminal, means they must consist of positive particles. So these anode rays, these are anode rays. These anode rays consist of positive particles. Okay, so discovery of proton, I have no need to explain. Just everything is just opposite to cathode rays, what we discussed. Suppose cathode rays are moving from cathode to anode, but anode rays are moving from anode to cathode. Understanding everyone? And one more important thing is those cathode rays. Cathode rays are invisible. Anode rays also invisible. Cathode rays are deflecting towards external anode, but anode rays are deflecting towards external cathode. Full opposite. Okay, so cathode rays are deflecting towards south pole in presence of external magnetic field. But here also, anode rays are deflecting towards north pole in presence of external electric field. Those all things we have to remember, please. Okay, so these are the most important things. And one more thing, I told you cathode rays are independent on nature of gas. But here anode rays are depending on nature of gas, what we taken in a discharge tube. Got it, everyone? So cathode rays are independent on nature of gas, but anode rays are dependent on nature of gas, what we taken in discharge tube. This is the most important thing. So please remember a few things here, what I said. You also write down anode rays, anode rays moves straightly. Anode rays move straightly from anode to cathode. Moving straightly from anode to cathode. This is the most important thing. Okay. Next important point is anode rays also invisible. Anode rays also invisible. Who is invisible? Anode rays also invisible. Anode rays also deflecting or not? Yes, deflecting. Anode rays deflects towards what? Towards external cathode. Anode rays deflects towards external cathode in presence of your internet connection is unstable. In presence of in presence of external in presence of what? External. In presence of external external electric field. In presence of external electric field, the anode rays are deflecting towards external cathode. Please remember this one. Same story, you have one more. Anode rays are deflects towards north pole. Remember this one. Towards north pole. In presence of external magnetic field. Okay. Will you write? Okay. In presence of, see, all these points are important. So of course, this is all introduction only. So actually, this particular atomic structure will start from electromagnetic radiation. From there, you will have more numericals also. This is the theory part. Definitely, you may feel some bore, but you have to learn. It's like a knowledge. See how electron discode, how proton discode, how neutron discode. Actually, no use exam point of view, but we have to learn. Okay. So as I said, cathode rays are independent. I said, based on, independent on nature of gas. But here these are dependent. So that point also important. Anode rays are dependent. Anode rays are dependent on nature of gas. This is the most important. So anode rays are dependent on nature of gas. So what you observe here, cathode rays and anode rays are traveling in a discharge tube in opposite manner. Cathode rays are traveling from cathode to anode. Anode rays are traveling from anode to cathode like this. Full up, full down. Okay. So this is the discovery of particular proton. So suppose if anybody asks you what is the E by M value of proton, if anybody asks, what is that? E by M value of proton means what is the charge of proton? Charge is 1 point plus 1.6. See, as I said many times, you have no need to think about the plus and minus. Okay, that plus and minus indicates that a negative particle or positive particle. Electron charge we use minus 1.602 into 10 power minus 19. But for proton we use plus 1.602 into 10 power minus 19. So the charge we have to take, that's it. The minus indicates negative charge, negatively charged particle. Who is that? Electron. Okay. For proton we use plus 1.602. So you can write them simply plus 1.602 into 10 power minus 19 coulombs by, so this is in coulombs, right? In kg you have right SI units. Okay. So what is the mass of electron? 1.674 into 10 power minus 27 minus 27. You have. Got it, sir, everyone? So E by M value of a proton is 1.602 into 10 power minus 19 coulomb by 1.674 into 10 power minus 27 kg. If you only simplify so that you will get E by M value of proton. If you cannot, then you ask me, I will tell you the simplified value for E by M, for a proton E by M value. Okay, for proton. So E by M value is important. Charge important, mass important. Those you must learn. So these are the points what we discussed. You can check once. So anode rays diagram, how discovered by Goldstein, and they are moving from anode to cathode in opposite manner of cathode ray path. Okay, so anode ray moving from anode to cathode, they are invisible. They are also, we can observe as a flash on a zinc sulfide screen, and high voltage battery we are using, and these are the just properties of anode rays what we have. You can check those. Got it? Thank you. So this is about E by M ratio of a proton. Next is discovery of neutron. See, discovery of a neutron was done by Chadwick. Who is that? Chadwick was discovered a neutron. Actually, till Rutherford atomic model, many people thought that the atom consists of only two fundamental particles. One is electron and one is proton. Electrons are revolving around the nucleus as planets revolving around the sun. Many people thought that only actually. See, as a planetary model, everybody knows that. Around sun, planets are revolving. Like that, around the nucleus of atom, electrons are revolving. That nucleus consists of protons only, they thought. But later on, Chadwick concluded that yes, nucleus consists of two particles. One is proton, not exactly one proton, many protons. Protons in the nucleus and neutrons in nucleus only. So who concluded? Mr. Chadwick. So this person, Chadwick, concluded that what? Neutron. Neutron means what? Neutral particle. See, he was bombarded beryllium sheets. Do you know beryllium atomic number? Atomic number is 4. And mass number is actually beryllium 11. Next, it bombarded with helium. Do you know helium? Okay. So about isotopes, I told you in bridge course. Don't worry. Who was not there in the bridge course? Don't worry. We will repeat all these things again. What are isotopes now? 4 is the atomic number of this beryllium, and 11 is the mass of beryllium. Same helium atomic number is 2, and 4 is the mass number. So he bombarded beryllium sheets he was bombarded, and he got carbon 4 plus 2. See here, 4 and 2, 6 atomic number atom is what? Carbon will come. 6C 40 and 0 0, because total atomic number you have here only 4 plus 2, so remaining is 0, and 11 plus 4 15, so 14 you have, so 1. So this particle representation is called neutron. What is that? Neutron. So please, discovery of neutron, how done by Chadwick, please try to understand. So beryllium sheets he was taken, because beryllium is a soft metal. Through beryllium sheets, he sent helium gas. Helium is a lighter gas actually, so it comes with more speed. So when this helium gas hits the beryllium, that converts to carbon and release some neutral particle with one mass. One, you can check there, the mass is 1. 0 you have at the bottom, and at the top you have 1. You can check here. So 0 and 1. This is called neutron. Got it, everyone? So, sir, how we can say some neutral particle came out, or neutral particle ejected? Ejected means came out, removed. Okay, so how we can say means, see here, if you check carbon, you can say some other particle came out. How I can say? See, 4 plus 2, 6. 11 plus 5, mass should be 50, but here you have 14 only. Experimentally they done how 14 means, we cannot weigh like 1 kg, 1 kg apple, like that we cannot. Yeah, see, experimentally by sending rays they will get weight actually. Okay, so we got 14. So what about remaining 1? So okay, with 1 mass, some neutral particle ejected. So we have one more doubt, sir. How we can say that is neutral particle? How we said electron is a negative particle? Tell me. Because if you kept some electric field, the cathode ray deflects towards a positive. That means the cathode ray consists of negative particle. I can conclude, because they are moving towards positive. So cathode rays consist of negative particles because they move towards positive. Similarly, anode rays are moving towards cathode at the same time in presence of external electric field. Those particular anode rays are deflecting towards external cathode. Means, what is the meaning of that? Yes, anode ray consists of positive particle because they are moving towards negative electrode. So we can say like that, they are deflecting towards anode or cathode. They means who? Cathode rays and anode rays. But here this Chadwick also did the same, copied. He is also copied person like me. Okay, what he did? He also kept some electric field and magnetic field for the bombarding of beryllium and helium. Then he observed there is no deflection of this particular neutron. Means these neutrons are not moving towards external anode. These neutrons are not moving towards external cathode. We can say these are neutral. Correct or not, sir? Suppose I'll give you one example. My parents are trying to, okay, I'm a single now, suppose I'm not married. So they are searching for a partner for me. Unfortunately, I am rejected. What is the meaning of that? I am neutral. Of course, I am not neutral. I am married and I have 2 children also. Don't think like that. But why I given that example? I'm a neutral means I won't think about anything else. I will say no, I'm not interested. Like that, neutron also neutral particle. Neutron is a neutral particle which is called Kazarare. Kazarare batch. You know Kazarare means neutral. Got it, everyone? So neutron is a neutral particle. So this won't deflect towards any external anode or cathode. Understanding, sir, everyone? Okay. So what I said, neutron is a neutral particle which won't deflect towards any external anode or cathode. Got it? So what is neutral understood? So they won't attract towards any external negative or positive. Okay, sir. So this is about the discovery of neutron. What he did, he taken beryllium sheets and he sent helium gas, and the beryllium converted into carbon, and one neutral particle came. That neutral particle is not deflecting towards any external anode or cathode. Any external anode or cathode. Got it, sir, everyone? Okay. So neutron is a neutral particle. Neutral particle means Kazarare. Kazarare means what is the meaning? Kazarare, Kazarare, meaning. Okay. Videos. So discovery neutron also over. So we had three. One is electron discovery, proton discovery, and neutron discovery. Now atomic model. First atomic model was given by J.J. Thomson. So electron has a E by M value. Proton has a E by M value. But neutron don't have any E by M value because charge is zero. Charge is zero for neutron. As I said, neutron is a neutral particle. You write down. Neutron is a neutral particle. So position of electron, proton, neutron to understand, we have atomic model. J.J. Thomson. J.J. Thomson atomic model. Atomic. J.J. Thomson atomic model. Okay, so what is the meaning of atomic model? First I'll tell you. So in atom, what are the particles? We have idea: electron, proton, and neutron. Hope you understood. There are, excuse me, there are three fundamental particles: electrons, protons, and neutrons. Now we have one question definitely. What are the positions of those? Got it. So I know in a human body, two eyes, one nose, two ears, one mouth, like that. I know two hands. But what are the positions? I don't know. What are present? I know. Now, what are the positions of those? I don't know. So then we have to understand that by using these atomic models. This is the second class only. Just go slowly, but the class must go smoothly. Okay. So that's why I'm telling all these things. Please try to understand. So now we have to understand positions of electron, proton, and neutron. That's why to understand electron, proton, neutron positions, where they're situated. So to understand, we have atomic models. The first atomic model, what we have and given by Mr. J.J. Thomson. Who given the first atomic model means J.J. Thomson. Who said about atom first means Dalton. Who said? Dalton said first about atom. Matter consists of tiny particles which are called atoms or molecules, he said Dalton. But first, who discovered a fundamental particle means J.J. Thomson. First, who given atomic model means J.J. Thomson. See, what J.J. Thomson said, according to J.J. Thomson, atom is a spherical, he said. Atom is spherical. Okay. He compared, Mr. J.J. Thomson compared atom with a watermelon fruit, or else cake with the plums. In cake, if you see different colors, we have plums, right? So like that, he imagined, he compared atom with the watermelon fruit first. He said, as seeds embedded in watermelon fruit in a red area, electrons are embedded. Electrons are embedded in neutral space or positive space of atom, he said. I repeat it. First, here, this is the red space. White. This is the actually total atom space. Okay, so here we have this is the positive space of atom, spherical. See, you can no red only better because the watermelon fruit is red color. Or like this I use. So here we have atom, and this is the space in atom actually. So now we have what negative particles like this. Here what you have negative particles. Okay. Oh my God. So this is what positive area. Positive area of atom. Who said? Mr. J.J. Thomson. So in positive area of atom, these electrons are situated as seeds embedded in watermelon fruit. So this is actually what negative space electron. So electrons are embedded in watermelon fruit, okay, as electrons. Watermelon fruit. Oh my God, sorry. Electrons are embedded in a positive space of atom as seeds embedded in watermelon fruit. So this was given by Mr. J.J. Thomson. So what said J.J. Thomson? J.J. Thomson compared and he given one particular information to everyone in this world. What he said, he compared atom with the watermelon fruit or plums, okay, plum cake. Understanding everyone? So, and what he said, atom is a spherical, he said first. J.J. Thomson said, atom is spherical. First. Atom is spherical and as seeds, embedded, as seeds embedded in, as seeds embedded in watermelon fruit, watermelon, okay, electrons, electrons embedded, electrons embedded in positive space, positive space of atom, he said. Who said? Mr. J.J. Thomson said. So this is about J.J. Thomson atomic model. Understood? But this is failed atomic model. Some drawbacks are there. He was unable to explain neutrality of atom. He was unable to explain proton's position. So this J.J. Thomson atomic model is a failed theory. So after J.J. Thomson atomic model, Rutherford atomic model was introduced. So this was failed theory actually. Rutherford also, but you have some information. You can have some information here actually in Rutherford atomic model. So that we have to discuss. So next here drawbacks are what? What are the drawbacks also I know? Drawbacks. What are the drawbacks? Here we have some drawbacks. The first one, drawbacks means failures. He was unable to explain. He was unable to explain neutrality of, definitely this is failed because neutron was neutron place and about a neutron was not explained first thing. So neutrality of atom, how exists, he was unable to explain, and he was unable to explain stability of atom also. So he was unable to explain neutrality of atom. So according to this J.J. Thomson atomic model, atom is unstable because electrons are present in a positive space station. So electron are besides, definitely they have some repulsions. So how the repulsions can be overcome? So he was unable to explain. So he was unable to explain neutrality of atom. And the second one, he was unable to explain, unable to explain stability of atom. Stability of atom. So these are the failures actually. So according to this J.J. Thomson, what are the failures we have? We had now. So now these failures we have to overcome, right? So what are the position of electron and what are the position of proton? Those all things we have to understand. So to understand all these things, one another person given atomic model, his name Rutherford. Rutherford atomic model. What is a Rutherford atomic model? Most important. Rutherford atomic model, what he given is, he given position of electron, he given position of proton, and of course in atom he said most important thing, atom is a spherical, as Thomson said, okay, but atom consists of a nucleus, and around nucleus electrons will revolve as planets revolving around the sun, he said. Mr. Rutherford atomic model. Okay, to give that information, what he did one experiment. He was considered gold foils. What he considered? Spherical manner gold foils, thin gold foils he was considered. And through gold foils, so these are the gold foils actually. So gold foils consist of nucleus. Yes, this is the nucleus. And he sent through gold foils, he sent alpha rays. What he sent? Alpha rays he sent. Alpha rays he sent through the gold foils. So remember, what are the alpha rays? I'll tell you everything. Alpha rays means what? Alpha rays means di-positive helium ion. Remember this, di-positive helium ion. 2He plus. 2He4 no, but plus 2. This is alpha rays. So yeah, alpha rays you can write like this also. These are what? Alpha rays. Alpha rays. You can represent like this also. He plus 2 ions. He plus 2 ions are called alpha rays. So what he said, he was considered gold foils. What he considered? Gold foils. See, experiment, please try to understand first. Rutherford considered gold foils. Gold foils are spherical thin plates, 10 mm, okay, thickness, very much thin plates he was considered. Gold foils we call it. Gold plates or else gold foils. Through gold foils he taken, and through gold foils he sent alpha rays. Alpha rays means what? Helium plus 2 ions. Helium plus 2 ions. Otherwise, Dipositive helium ions. So what he observed, maximum of the alpha rays are passing through the gold foils. Maximum of the alpha rays are passing through the gold foils like this. So, but maximum of the rays are passing like this. But he observed the rays which touches the center, they are deflecting back with the 180 degrees like this. Of course, I'm showing like that, but the rays which touches the center, they will come back in the same manner backside. See, this is the ray hits the center of atom or gold foil. They are coming back in the same path like this. But just to show that deflection, I'm writing downwards and upwards this deflection. So now let's discuss about that Rutherford atomic model, what he did, experiment, what he did, try to understand first. Afterwards, from the experiment, what he given, then we will discuss. Two things we have to discuss. What he did experiment, first thing. And the second thing, from the experiment, what we can understand. Okay, what he given for us. Those are important actually. So first, what he did in a Rutherford atomic model. First, he considered gold foils, which is a 10 mm of thickness. Okay, so gold foils he kept like this, and through the gold foils he sent alpha rays. Maximum of the rays are passing through the gold foils. What he observed? Maximum of the rays are passing through the gold foils. See, around 10,000, just one or two rays are coming back. See, maximum of the rays are passing through this is the gold foil, suppose. I'm sending alpha rays like this. Maximum of the rays are passing like that. They are not coming back. Getting what I'm saying? This is gold foils. So through this gold foil, I'm sending rays like this. So maximum of the rays are passing through the gold foils. So I send from here, they are going like that. But one or two rays which touches the center, they are coming back with the same angle. Means same path. Means with 180 degrees angle, the rays are coming back. So what is the experiment? Hope you understood. Taken gold foils, and through the gold foils you send alpha rays. Alpha rays are called dipositive helium ions. So alpha rays are positive ions. Alpha rays are positive ions or negative ions. So you must know this. So we send alpha rays. So alpha rays are positive rays. Remember this. Alpha rays are positive rays. So what we can understand by using this Rutherford atomic model, yes, maximum of the rays are passing through the gold foils. So except that particular space, except the center, the remaining space of atom is empty. That's why the rays are passing through the gold foils. That's the meaning. So please try to understand, everyone. So the rays are passing through the gold foils. So that is what is the meaning. So atom consists of two things. One is that nucleus, and remaining space is empty, he said. So what he said, the first point, atom consists of nucleus. Atom consists of nucleus. How he said atom consists of nucleus? Because he sent some positive rays, but the rays which touches the center of that gold foil, they are coming back. That means that center he named as nucleus, and atom consists of nucleus, and that nucleus consists some positive ions. Atom consists some positive ions inside. Okay, those positive ions are called positive particles. Sorry, not ions. Those positive particles are called, what they are called? Protons. Positive particles. Those positive particles only called, what they're called? Protons. So except nucleus, the remaining space of atom is empty. Please remember this one. Except nucleus, the remaining space of atom is empty. That also you please write down. So you have to write like this. Except nucleus, the remaining space of atom is empty. Remaining space of atom is empty. See, the positive rays, cathode rays are, sorry, alpha rays are positively charged. So they are moving, they are passing through the gold foils except the nucleus. Means what is the meaning? Around the nucleus, there are negative particles present. What particles present? Next point. So this is the meaning. Alpha rays are passing through gold foils. Passing through gold foils. That is, what is the meaning? Alpha rays means what? Positive. Alpha rays means what? Positive. So alpha rays are passing through gold foils means what is the meaning? That is except nucleus. Except nucleus. Remaining space of atom. Remaining space of atom consists of what particles? Negative particles. Negative particles. What are those negative particles? Those negative particles are called electrons. We have some clarity now. So according to Rutherford, we had one clarity. Atom is spherical around nucleus. Here you have a nucleus. So at the center of atom is called nucleus. The nucleus consists of positive particles. Those positive particles are called protons. Around this nucleus, electrons are present. How electrons are present? In tomorrow class we will discuss. Okay, electron and few more things we have, but time over, and so that we will discuss tomorrow. So how electrons are present, how the electrons are revolving around the nucleus, and some drawbacks in Rutherford atomic model. These all things we will discuss tomorrow. But from tomorrow class, definitely I can tell you that you will have numericals also, because wavelength, wave number, frequency, energy, these all formulas we will discuss. So from tomorrow class is very, very important. So please. Okay, thank you very much. Right.